Roger Grabman, the State President of the Georgia Society of Professional Engineers. Welcome to the inaugural live virtual meeting of the Atlanta Metro Chapter. Regardless if you are a local member or a guest at some distance away, we are delighted that you are with us tonight. I am proud to be a member of GSPE, while other organizations had to suspend activities. The Atlanta Metro Chapter is continuing to serve the engineering community with a useful, informative program and do so safely. According to the ethics of professional engineers, the welfare, health, and safety of the public is paramount. I trust that you will find the program tonight interesting and valuable. Please check out the other recordings on our YouTube channel.
Good evening, everyone. My name is Steve Strong. I'm the past president of the Georgia Society of Professional Engineers and the Atlanta Metro Chapter as well of the Georgia Society of Professional Engineers. I hope everyone's having a great evening, and welcome to our first ever live online presentation for one of our professional development hours. Just a quick little bit of housekeeping. If you have any questions for the speaker, go ahead and type it into the chat box on YouTube, and I will try to monitor that, and I will relay that question to the speaker on your behalf at the appropriate time. With that, I'd like to introduce Jesus Sandoval for some introductory announcements.
Thank you, Steve. Good evening, everybody. My name is Jesus Sandoval. I am the current president of the Atlanta Metro Chapter of the Georgia Society of Professional Engineers. We have a great topic here for you this evening, but before we get started, I want to make a couple of announcements. I want to encourage you, if you haven't already done so, to join us via YouTube. We have our own channel now, LinkedIn group, and not just join us, but if you could please spread the word and encourage others, friends, colleagues to join us as well. There are a couple of activities that we at the Georgia Society of Professional Engineers support. One of them is the Georgia Engineering Foundation, and the Engineering Foundation runs an academy annually for middle school graders to spend a week learning about all the different engineering disciplines. Unfortunately, this year, we do it normally at Georgia Tech, and given the situation that we're in, it's not going to happen on-site physically. It's going to be a virtual meeting. But we are looking for any type of presentation material or different projects that you might have worked on that you could share with the kids. Also, if you'd like to volunteer to be a presenter, please let us know, and we greatly appreciate that. Also, another big event that we are part of is Math Count. And for those who don't know, Math Count is a competition that goes from the local levels all the way up to national. Unfortunately, this year, given the circumstances, we only got as far as state. But as you can imagine, there are many activities that take place throughout the year to raise funds for this. And so one announcement that I'd like to make is that an auction for 4 Stone Mountain golf passes. If you need more information, I encourage you to go to our page, gsp.org, or simply send any of us an email, and we'll be glad to forward any information to you. Okay, for tonight's speaker is Lucian Gavriliuc. I'm sure I butchered that name. I am sorry, Lucian. He received a BS in Electrical Engineering from the University of Houston and an MBA from the UGA Terry College of Business. He became a registered professional engineer in 2014, and in his career, he has worked on power plant, electrical distribution design projects for the pulp, paper, chemical, and mining industry. He conducts power distribution studies for small and large-scale facilities and conducts arc flash assessments. Lucian joined Hargrove Engineers and Constructors in 2018. In addition to his GSPE membership, Lucian is also a member of the Atlantic chapter of IEEE. And without further ado, please join me in welcoming Lucian.
All right. Lucian, you are up.
All right. Good evening, everyone. Thank you for joining me and the GSP team for this webinar presentation on changes and updates of the Nfpa 70 National Electrical Code 2020. My name is Lucian Gavriliuc, and I'm a registered professional engineer in the great state of Georgia and a couple other states. I've been practicing engineering for 20 years. Much of my experience has revolved around designing electrical systems for power plants and industrial systems such as pulp, paper, and chemical industries. This evening's agenda will be National Electrical Code 70 overview, and new deleted articles in NEC 2020, systems and grounding, Article 500, special occupancies, Article 625, electric vehicles, power transfer systems, in Chapter 8. So this evening, I prepared the material with the thought in mind that many of you may not be necessarily electrical engineers or electrical designers or electricians. So I thought to talk about installation aspects which involve other disciplines. The agenda is as I discussed, and I wanted to present this agenda in a way that it applies to other disciplines, because the code itself covers many aspects of electrical systems. So this evening I've chosen to discuss only specific items such as the system grounding and special occupancies in electrical vehicle power systems. The NEC has been around since 1897, if you can believe it, and was drafted as a result of the united effort of various insurance, electrical, and architectural, and allied interests. So the National Electrical Code is not pure electrical engineers, but we had insurance interests, we had architectural interests. Also, this publication, the Nfpa publishes this 70 edition every 3 years, and this latest edition is the 2020. So let's have an overview of the book. Now I have a copy here. Actually, I have several copies, and this is the 2020 edition. I also got the 2017 and a few prior editions. But one thing to note when we look at this text is that the book itself starts with acknowledgments, and then you have a summary of technical changes. And in the summary of technical changes, we're presented with what has changed from the previous edition. Changes throughout the code are marked in the following manner. So text revisions are shaded. So when we look at the code book, you will see a text that is shaded. That's a revision. A delta symbol before a section number indicates that words within that section were deleted, and a delta to a left of a figure indicates a revision to an existing table or figure. When a chapter was heavily revised, the entire chapter is marked with a delta symbol. Where one or more sections were deleted, then you can see this dot. So often you would come across sections and you see that dot in the text. you would know that way something was deleted from that text. And also, when they added new material, they have an N next to the chapter or the section that was added. Now, the Nfpa is divided into 9 chapters. Excuse me for a second. So I would like to cover the chapters because, like I said, some of you may not be familiar with the text. So chapter 1, with that, before I get started, I wanted to make to mention that I will not go through every article because there are many articles that we'll see. I will just summarize the text, just the chapter, and in a couple of cases, in a few cases actually, where we're going to be discussing particular articles in our talk this evening, I will mention those. But the most part, I'm just going to mention, how many articles are in the chapter, just for you to get an overview of how big this book is. So in chapter 1, we find the definitions article, and that is Article 100. Also in chapter 1, we found Article 110, which is the requirements of electrical installations. Of course, this chapter has 2 articles. Chapter 2, wiring and protection, is comprised of 9 articles. But look, we will only be discussing about Article 200 and Article 250. In Article 200, we see that, well, this chapter, actually, before I get there, this chapter is called Wiring and Protection. So I just wanted to mention this. When we look at the words wiring, and what do we understand by that? So in this chapter, we're presented, for example, with wiring colors for the wires that an electrician drills with. So on a 480 volt Y 277 system, a phase A is brown, phase B is orange, and phase C is yellow, and the neutral is gray. So if you go to an installation to a power plant, you go to an industrial plant, if you encounter these colors for power cables, you will know that those are those specific phases. But what about protection? So you've got wiring and protection. And protection has to do with protecting the feeder, the conductors, so those cables that you see, the feeder conductors and service conductors. Throughout this text, there are other articles which cover other specific items like motors and transformers, and I'll mention some of those. Chapter 3 covers wiring methods and materials. How are cables installed? Are they installed in cable tray or underground conduit duct bank, or within walls of a building or house? So this chapter has 47 articles that goes over that. Chapter 4 covers equipment for general use, such as motors in Article 430, air conditioning and refrigeration equipment in Article 440. So if you want to know how you're supposed to size cables, how you're supposed to run conduit, anything, protection, that chapter those specific chapters will have that information, but sometimes they may refer you to back to the protection in chapter 2. Also transformers in Article 450, and these are I've just named a few. If you notice, there are 21 chapters, 21 articles in chapter 4. So there are other items that are listed there. Chapter 5, special occupancies, which has to do with hazardous locations. And chapter 5 is also a chapter that I will discuss a little bit later on, and because it's of importance. So what about special occupancies and hazardous or classified locations? Well, the NEC divides the materials that I will mention in 3 categories. So class 1 location would be a location where it contains flammable gases, flammable liquid produced vapors, or combustible liquid produced vapors, which are or may be present in the air in quantities sufficient to produce explosive or ignitable mixtures. So that's class 1. Class 1 is gases. What about class 2? Class 2 locations contain combustible dust. So I was trying to think of an example of combustible dust. Would you consider that the cereal or grain silos may be a hazardous location? So I found this interesting tidbit. According to Department of Labor, there have been over 600 explosions in grain elevators over the past 40 years, killing over 250 people and injuring in excess of 1,000 others. Now, this excerpt came from an IEC E-Tech issue dated March 2014, which is a little bit dated now. It's over 6 years old. So, yes, you will guess location 2 could be grain silos. What about location 3? Location 3 contain easily ignitable fibers or flyings. So, as you see, Chapter 5 deals heavily with other disciplines because we have in Chapter 5 we got, as an electrical engineer, we need to know what material is going through a pipe, for example, if you have a methane gas or if you have any other gases, or if your environment is able to produce a spark. So, or does it get hot enough where it will produce a spark? Going on to Chapter 6. Chapter 6 covers special equipment. And what is other special equipment? Electric signs and outline lighting in Article 600. Elevators, dumbwaiters, escalators, moving walks, platforms, lifts, and stairway chairlifts in Article 620. So when we want to do an elevator, if you have an elevator that carries people, that carries just material, those are different requirements that go into that. Electric vehicle power transfer systems in Article 625, and I will be talking about this later on also. Mobile data centers in Article 646. Solar photovoltaic PV systems in Article 690. So you've seen a lot of places where they started putting photovoltaic, PV systems. So 690 covers that. Also, Chapter 6 has a total of 27 articles. Chapter 7, special conditions where normal electrical supply system is interrupted and emergency and standby systems are implemented. So these will be hospitals or where you have to have emergency systems or even standby, right? Some, if you look at data centers, they use standby generators. So some of these are covered in these chapters. And finally, Chapter 8 covers communication systems. This chapter has underwent some major revisions during this 2020 cycles, but it includes 6 articles. Also, Chapter 9 are tables, and in these tables you will find conduit fill based on either 3 conductors or how many conductors can you put into 1-inch conduit. And it looks at the size of the cable. And also you can find impedances. So if we have to do a voltage drop calculation and you got a 4-aught cable, it gives us impedances to be able to do that. And in Chapter 10, you have the annexes. And those, again, are tables. And also, they're in certain annexes, they help either the engineer or the electrician to do certain different calculations that need to be done. So in 2020, like I said, we have some new articles. So Article 242, over voltage protection. These, from the 2017 issue, in 2020, the articles that make up the new 242 are Article 280, surge arresters, which are over 1,000 volts, and Article 285, surge protection devices, 1,000 volts or less, where combined So that's what comprises 242. What about Article 310? 311. This article consolidates requirements previously appeared in Article 310 and Article 328. The MV cables are rated 2001 to 35,000 volts. And also the MV cables, which is medium voltage, are installed in underground installations must comply with Article 300.50. So that's the change that has been incorporated in Article 311. Article 337 has to do with P-type cables. I'm not sure how many of you have used P-type cables, but this is a marine shipboard cable. It is flexible, resistant to some chemicals, and resistant to abrasives. It is intended to be used on land-based oil and gas well drilling, where units are often transported between drilling sites. The product standard for P-type cable is UL 1309, standard for safety marine shipboard cables. So some P-type P cables have a metallic basket weave braided armor to improve durability. So this is some things that have been incorporated in Article 337. Now let's get to Article 800. Article 800, which is Chapter 8, has been reorganized for the 2020 edition of the NEC with the intent of minimizing redundant requirements across Chapter 8. In the past, when I've attended these type of classes, I was told that Chapter 8 was all on its own. So a lot of topics were kind of, you had the first 7 chapters and then Chapter 8. So, but what NEC is trying to do, I believe, is that they're trying to harmonize Chapter 8 with the rest of the NEC. The new Article 800 was created to contain the general requirements for communication system. What was Article 800 in previous editions of the NEC has now become the new Article 805. So whatever was there in 800, now it's 805. While the rest of the chapter remains the same with respect to numbers and titles. Article 805, communication circuits, contains the requirements that are unique within Chapter 8 for communication circuits. So we will go through this a little bit later on. Deleted articles in the 2020 NEC. We have Article 280, right? So we mentioned that on the previous slide, and 285. They were deleted because they now make up the 242. Article 328 is now part of Article 311, and these are the medium voltage conductors and cables, which is type MV cable. And Article 353, requirements for floating buildings, including floating dwelling units, are now covered in Article 555. All right, you may have to squint a little bit, but there's a lot of writing on this. So Article 200, and this is use and identification of grounded conductors. So I'm going to try to pronounce words very clearly because when we talk about grounded conductors and grounding conductors, we are talking about 2 different things. So let's start with 200.3, revision to clarify applicability and recognize that inverters can be interactive with other electrical power sources. Now, I've got some pictures coming up. So if you don't know what an inverter, what I'm talking about, electrical components, I'll present some pictures after this slide. 200.6, revision to correlate with Article 690, requirements for grounded systems and to allow single photovoltaic conductors to be identified in a similar manner to grounded conductors of other systems. So again, the first 2 items of this 200 are related to PV, to photovoltaics. Inverters are used in photovoltaics to convert solar energy into electricity, and that is, and they're collected into inverters. Inverters convert DC current voltage back to AC. So that's what those functions are. 200.6 revisions to align 200.6e revisions to align requirement on identifying the conductors of multi-conductor cable with the general grounded conductors identification. 200.9 recognize that silver coloring of terminals for the grounded conductor is more frequently used. Example, equipment with polarized connections. So you might think from a different discipline, this is kind of mundane, kind of basic, but these are the type of changes that are recognized in the NEC, and the NEC is really an installation guide. It tells an electrician how to connect equipment. So we have to be very detailed on how we do that. So 200.10b revision to recognize that most devices have silver colored terminal screws. And these are receptacles. So if you look at the receptacle in your house, and I'm not exactly sure what is driven. It may be driven because the market, maybe perhaps where we manufacture the equipment. So a lot of it is manufactured across the oceans, and to make it cheap and fast and cheap. Well, if you make everything the same, you have to produce everything the same in the same specs, then everything comes out really fast. If you have to make different colors and different specs, then things get produced a lot slower, and maybe cost is associated with that. So as I stated before, photovoltaic panels, I'm sure you've seen them. Some people may have them at their house, but here on the left side, this is a picture of photovoltaic panels. Now, an inverter is this box right here on the right. So you will see that a lot of these things, depending on the size of the let's say of the supply of the power producing entity, they may have one, a limited number of PV panels that go into a module and then go into a PV inverter, or they may have multiple modules that are collected into a PV, and then they go to a transformer. So with that, I would like to talk about a very important article, and it's near and dear to my heart because I have to deal with it very extensively. So this, I'm going to mention this. This is a graphic I produced, but it's based on Exhibit 250.15. So what do we see in this picture, other than some triangles, maybe a Y, some panels, a box? So in this picture, what we see are some components. But before I get that, I wanted to ask, the goal of grounding is to have one voltage reference at a facility so that we protect people and equipment. In our example, we are looking at a very specific case. So let me reiterate that. This is a very specific case we are looking at. In this case, you would sometimes hear people talk about transformer delta Y. And that's what this, or Y grounded. Let me make specific. This is a Y grounded transformer. So we have a delta winding. This is how we represent a delta winding. You have your three phases, A, B, C. And then we have a Y winding, and it's represented with this Y here. Also we have three phases that go to a breaker. So let me get started here, and let's identify some electrical components in this picture, and that is, this is a transformer. So what I've identified here at the top is a transformer. Based on the code, we'll call this a separately derived system. So when I hear the word separately derived system, most likely they're talking about a transformer. They could be talking about a UPS, uninterruptible power supply, but most of the time, we're probably talking about a transformer. So in our case, this is a delta. I mentioned that already, delta Y. So we've already mentioned the colors of the phases. So phase A is brown, phase B is orange, phase C is yellow. But what about the phase colors of the Y winding? So again, if we go back to Article 200, it will tell us what the colors are. And those colors are phase A is black, phase B will be red, and phase C will be blue. And the neutral is white. Now, for clarity, I didn't put a white conductor here, but trust me, this is a white neutral. Oh, sorry, I clicked too fast on my screen here. Let me go back. And I think this got stuck a little bit. There you go. Sorry about that. Next, so as part of this transformer, I want to identify this terminal bar. So inside of a transformer, you'll find a terminal bar if it's wired this way. Typically, this is okay, so then after the terminal bar, we've got a ground rod or ground electrode. So this component is not in the transformer anymore. It is usually a rod that's driven in the ground. Now, for NEC, the minimum required length for this rod is 8 feet, but you typically see these in 10 feet length. So, and per NEC, you're going to be at about 30 inches depth. And that's because your ground grid that has to go around your facility is at a 30-inch depth. All right. What else can I, excuse me, let me drink water. What else can we identify in this picture? We can identify a system bonding jumper. So you can see this ground bar has a little jumper, a little cable that is tied to the case. So that's what this dot means here, and the case of the transformer. So this represents the case. So we've got one ground system bonding jumper that's tied to the case. We've got a grounding electrode conductor that goes to grounding electrode. The next item I would like to identify is the power distribution panel. So you notice that there are two cables coming from the terminal bar. One is this brown supply side bonding jumper, and one is neutral. So this is where the confusion is with this whole system. Each of these two, even though they're connected at the terminal bar, they play two very distinct functions. One, which is the supply side bonding jumper, but also in certain cases, if you look at a different equipment, we'll call it equipment grounding conductor. But in this case, this conductor will only be used to make the case of the power panel and the case of the transformer at the same potential. So they're connected, and they by the virtue of being connected together, they are at the same potential. Now, what about this neutral? So you notice there's one cable, and this is a jumper. We can call this a neutral also, because the neutral point in this Y is this X0. X0 is what you would find on if you actually go to a transformer and you look at the connections on the back, you'll notice that there's one connection that's called X0, and that is the neutral point. That is the point that you tie to ground, or if you leave floating, you'll know we'll call that a floating ground. So, but in this case, this neutral gets tied to this. Now, why is it different than this other one? Because in certain cases, if let's say you have a 208 120, so 120 volt, the return path would be the neutral. It's not the grounding, the bonding jumper or the equipment grounding conductor, but is the grounded. So this is what we call a grounded conductor, because it could be used as a return path in a normal operation. Now, in normal operation, I do not want to have any current or voltage on this system that will hurt somebody. So if I go to this panel and I touch it, I do not want to be shocked or electrocuted. So that's what this function is for, this grounding, bonding jumper, and equipment grounding.
Okay, we have a question from the audience,
Yes,
if we may. So Adolfo would like to know, he says, please elaborate about NEC 70 when specified about PPE. He says he required a minimum of 40 watts per square centimeter. If more than, if more the EQ have to be work dead. So I think, I
have to look that one up because I'm not sure that's in the NEC. The arc flash, if we're talking about arc flash, and that's what it sounds to me. I would then that's Nfpa 70E, but I don't recall 40 watts per square centimeter. If when you talk about 40 watts, I'll have to research that. So if I can, if we can take it down, and I will, I don't know, unless it points to a specific section, and I could research that real quick. I'm not sure about that standard or about that requirement.
Okay, Adolfo, if you want to clarify with a subsequent question in the chat box, we'll go ahead and try and address it then. Otherwise, we'll get back with you later.
So this, oh, I forget. All right, so as far as this picture is concerned, we have the three phases going to a breaker, and pretty much these are the components that have to do with a derived neutral, and we also call this that a derived system, not derived system, but we also identify that the point of connection, the grounding point, is at the transformer. So for that, because of this, this is a special case. Other places you'll find maybe the terminal bar is inside the breaker, which is the first point. But you know, and I don't want to overwhelm the audience with many.
Okay, looks like you are back. Give me just a second here.
Who was the gentleman that asked about the 40 watts? That sounds like lighting.
Okay. Yeah, let's see here. It'll be recorded in the chat. We'll look at it after. Let me the presentation's not come up yet. Okay. Okay, can you check the presentation on your end? I think we've got you back, but I'm not seeing your PowerPoint.
I had it stop the timer, but I haven't ended the slideshow.
Okay, actually, it looks like it's coming up now.
I can see me on
Yep. Okay. I think we're back. That was horrible. I don't know why I did that, but I think we're back, everybody. Sorry for the problems. Yep. Looks like you can go ahead and proceed, yeah, where you are, I would say.
So 250.30 or 250.58?
From what I saw last on my screen, I'd say start with 250.30.
All right, so let's talk about 250.30. Revision to clarify that multiple separately derived systems of the same type connected in parallel are considered to be a single separately derived system. So we've just discussed separately derived systems, right? So what's an example for us? An example are multiple power sources of the same type connected in parallel in an emergency or standby. So emergency generators would definitely fit this, be affected by this change. So the standby generators or the emergency systems are connected to paralleling bus or equipment where the transport arrangement switches the ungrounded and grounding conductor of the normal and alternate power supplies. So what does that mean?
Yep. Actually, we have a question for you on that topic. They're specifically asking, let's see, Richard was specifically asking, how is this grounding different from bonding?
So as far as, is this specific to 250.30?
He wasn't clear. I'm trying to go back through the questions and see.
Okay.
Actually, guys, I'll tell you what. If everybody, because of the problems that we had, if you would go ahead and re-ask your questions as it comes through when our speaker is at that point in time, that might help make it more clear for everybody. Sorry about that again.
So you're asking about bonding and grounding, but in this case, let me look at the 230 revision parallel are considered to be a single separate derived system. So we I went on to explain before the break here that these three conductors here are ungrounded. And why are they ungrounded? Because they're not going to ground. And so are these three on the delta side. Those are also called ungrounded conductors. Now, grounding, right? Grounding. When we're talking about grounding, electrode grounding, we're talking about this wire going from the terminal bar to the grounding electrode. Bonding. We're talking about a jumper going from a terminal bar to the case. In this case, we're also calling a bonding jumper the equipment ground, essentially. So the equipment grounding conductor is the one that goes to that attaches to other equipment. So a bonding jumper is one that ties the ground bar to the case, and a grounding is the one that goes to the grounding electrode. So hopefully that's clear as far as grounding and bonding. We're bonding to a case. We're bonding to I didn't show a motor here, but if I had a motor, I would be showing a bonding jumper to the motor if that required it. But so grounding electrode is this right here. A bonding jumper is the one that goes to the case. Now, essentially, these are on the same at the same voltage potential, because we have in this thermal bar, we're essentially making everything one point, just like that point right there. We're making everything because everything is connected electrically, is connected together. So hopefully that's clear of what it was meant by bonding and grounding. We're bonding to a case, and we're grounding to an electrode.
And I think we have a clarification on that prior question from Adolfo as well. It looks like he was referring to 40 cal per centimeter.
That's what I thought. 40 cal per centimeter, that has to do with arc flash, and that is Nfpa 70E. So this is Nfpa 70, but I'll be glad. That's another topic I want to talk about. I mean, I'm familiar with arc flash. Nfpa 70E, I'll just make a brief explanation because that's a different standard. I've got the standard here, but I got to get up and get it, so I'm not going to do that. At above, so any Nfpa originally had categories, if you remember that. Category 0, 1, 2, 3, and 4. And each category was assigned a specific calorie. Category 0 was less than 1.2 calories per centimeter squared. Why? Well, because at 1.2 calories, we get second degree burn on our skin. So 1.2 is very important. Then they went up to 4 calories. At 4 calories, you have to put in a coat, or you have to have a shirt on that can handle any incident energy issues at that level. Then you went to 12. Then you went to 25. Then you went to 40. At 40, they said, don't work on it, because if you work on it, you will die. Okay, if there's an explosion at over 40 calories, and let's say you dropped your wrench, the worst thing you can do is bolt, what we call a bolted fault. How would you do a bolted fault in the real nature? Or is to take your wrench and put it across the phases. That usually doesn't happen unless somebody drops the wrench. So over 40 calories, your bus bar disintegrates. When bus bar explodes, the heat that's associated with that is 5 times the temperature of the sun. I believe is about 20,000 Fahrenheit. You not only get the heat, you get a shock wave. And in Nfpa 70E 2018, which is the last one, but going forward, they're going to be looking at shock waves. That was not part of the thing that they were studying. So, but that's a side note. And I'm glad you asked that question. If you need further clarifications on that, let me know, and I'll be glad to answer them. But so moving on. Let's see, 250.68. All right, 250.68. Revision to specify methods of connecting rebar extensions to the grounding electrode rebar and prohibit utilizing rebar as a conductor to interconnect other electrodes. So we discussed this already. Actually, we discussed it, and I had an issue with this morning, talking about rebar. So this has to do with civil structural people that make foundations, that deal with footings. So what does this tell us? This change says that I cannot take this grounding electrode right here, connect it to the rebar of a footing, and I don't have an example here to show you, but let's pretend that there's a footing that's got rebar here and adjacent. So I can't take this grounding electrode, the cable from here, tie it to the rebar, and then tie that to somewhere else in the plant and call that as a system. What this revision says that we will have a grounding conductor, a ground loop, a ground cable specific for this purpose. So we're not allowed to use a rebar to interconnect other electrodes. All right, so now I'm shifting gears, okay? So we've been talking about grounding, we've been talking about cables, we've been talking about transformers, panels. How do you wire things? So we've been talking about the wiring aspect of an electrical system. Well, now we got Article 500. And Article 500 is special locations, special occupancies. So what does 500.1 state? 500 revision to include informational note number 4, that is existing text being relocated from the beginning of Article 500. So this particular informational note in NEC 2017 was at the beginning of Article 500. Now I looked it up. There was no note, so there was not informational note number 1 or number 2. It was just an informational note. So what they've done, they have taken that note from the beginning and placed it in 500.1 and gave it a information number. Article 500.5a, information note 2 contained a reference to ASHRAE 15 standard, which is now deleted. And reading about it, apparently ASHRAE has removed some references to whatever Nfpa 70 was referring to, and they had to make that clarification. Article 500.5c1.3, revision to require that all conditions involving Group E dust require Division 1 area classification. If you remember dust, right? Dust is a class 2. So I've mentioned grain and I mentioned cereal, but Group E dust have to do, an example is magnesium and aluminum. And these dusts, when they can, if they're in air, they can cause sufficient temperature rise or electrical arc to trigger ignition. So me as an electrical engineer, I have to be aware that the environment I'm putting the electrical equipment in, because I wanted to make sure, is it going to cause harm to people, cause harm to property? It basically has to do with what we did when we took our PE test to say that we're here for, we want to uphold safety. Well, Article 500 is very much for that. Okay, so let's jump to 625. Article 625 has to do with electric vehicles. And I chosen this one because electric vehicles are more prevalent in recent years. From my general knowledge, there were electric vehicles at the turn of the century. That'll be in early 1900s, from what I understand. I remember seeing I think maybe a Ford video that was a pickup truck I think in the 2000s, early 2000s. So there have been electric vehicles around, but they haven't been widely implemented. The first installation I saw here in Georgia was at Perimeter Mall. And my understanding was that they had built the charging stations back early 2000s. So electric vehicles have been around for a while. It's just that nobody's been able to produce them or to produce the batteries cheap enough where people can buy them. So Article 625, and you see there it says title, right? There was a revision to the title. And what the revision was to encompass bidirectional current exchange between electrical vehicle supply equipment and electric vehicle. So the title changed from 2017 to 2020. So in 2017, the article was called Electric Vehicle Charging System. In 2020, we call it Electrical Vehicle Power Transfer System. And I believe I have an explanation. I picked another, let's see. So before I go on to my next point, and what is the intent of Article 625? Well, the intent of Article 625 is to cover installations, safety requirements for charging equipment and for connecting the charging or the supply equipment to the electric vehicle through either a conductive, inductive, or, can you believe it, wireless power system. We have seen wireless charging for your cell phone and for your other small devices like maybe your Apple Watch or whatever. Well, they're also looking at wireless power transfer system for your vehicle if you've got an electric one. In addition, ventilation requirements aimed at preventing unignitable air-hydrogen mixtures are included in the requirements. Well, why would we be looking at air-hydrogen mixture? Well, the fundamental purpose of the NEC is to minimize fire and shock hazards. It's covered through Article 625 requirements covering the charger vehicle interface and the environment that is created by charging of some types of batteries. So as you see, when we deal with electric charging vehicles, now we have to consider the batteries. Are you lithium ion, cadmium? Are you, wet cells? What we call wet cells? Are you valve regulated batteries? So we have to look at that as electrical engineers. The use of electric vehicles as a power source for standby power or as an interconnecting source is also covered. So 625 covered these items.
So I have a question for you.
Yes, sir.
You mentioned the difference between conductive, inductive, and then wireless. What would you consider the difference between the inductive and wireless?
Let me think about that. Because I was just repeating what the actual note, what they were talking about. But microwaves, right? You've heard of microwave transmission. I'm not sure that could be a wireless transfer system.
Okay.
So instead of having a transformer or an exciter that you excite a transformer to like people are stealing, right? We're talking about induction, right? When somebody people that stole electricity from utilities, they put a toroid, a coil underneath the transmission line, and through induction they were able to charge whatever. But wireless power transfer, I would think has to do with possibly microwaves.
Okay, thanks.
Yep. So bidirectional connection is attractive to some consumers. So now we're talking about bidirection, right? The title here, it's bidirection of power. And some consumers maybe they may like the idea of being able to connect if you lose your power, like last night, we experienced some thunderstorms, right? And some people lost power. Well, if you had one of these systems, you can use the battery off your car to power up lights, for example, in your house. So bidirectional connection attracted to some consumer who would have otherwise used an engine generator or other alternative source. So this 625 covers that. 625.2, electric vehicle power export equipment. It's a new definition. An information note covering equipment used to export power to loads, to external loads where electric vehicle is used as power source. So EV supply, electric vehicle supply equipment comprises of the components between the skin of the electric vehicle and the premises wiring. So now we're talking, so now and again, I've got a slide coming up where I'm showing a charging station in a car. So it'll be a little more clear once we talk about this, and then we can show it. So the electric vehicle supply comprises of the components between the skin of the AV and the premises wiring, including any flexible disconnecting means, enclosures, power outlet, and AV connector. So the defined term includes all off-vehicle charging equipment and does not include charging equipment installed on the vehicle. So 625.2 states that we're dealing with the premises wiring and not any charging equipment on the vehicle itself. So let's go on to the next slide. So here we've got a picture of some electric vehicles, standby charging stations. So here's your charging station, and here's your flexible cord, and there you can see the connector that would go into the receptacle of it's not a gas tank anymore, but it's a receptacle on the battery system on the car. So that's what that's what we're talking about here. We're looking at this system and how we would charge it, how would we apply it by charging the car. All right, so chapter 8. Somebody told me that they wanted to hear some things about chapter 8, communication circuits and antennas. So here, chapter 8 has to do with what you see in this picture, communication circuits and antennas. But not just that, you'll notice in this picture, there are some electrical houses and maybe some generators. You may not have utility power, so you might have to go with standby generators, but the wiring going up to power these antennas. So, that's what chapter 8 covers. And there are different aspects of radio, television, satellites, so let's get into chapter 8. As I mentioned before, 800 is new article and contains common requirements currently found in articles 800, 820, 830, 840. So what do these 800, I will give you the titles for these. So Article 800 is communication circuits. Article 820, community antenna, television, and radio distribution systems. I just had a picture of that. Article 830, network-powered broadband communication systems. Premises 840 is premises-powered broadband communication systems. So they've taken all the general requirements that used to be in these articles, and they put them all into Article 8, what is now Article 800. Let's talk about 800.2. Relocation of definitions to the new article to provide a common definition that applies throughout Chapter 8. So with 802, they relocated definitions from other and added a new article. So let me give some examples. And some examples are abandoned cable. So in Article 800.2, you'll find a definition for abandoned cable. What does that mean? An abandoned cable is a cable not terminated at equipment and not identified for future use with a tag. That's one definition. What about communication circuit? So the communication circuit is defined as a circuit that extends service from the communications utility or service provider up to and including the customer's communication equipment. What about point of entrance? The point within a building at which the wire or cable emerges from an external wall, from a concrete floor or slab. So these are definitions that were collected from the others and put in 800.2. Article 805.170. New informational note too. Additional information regarding voltages, currents, and power allowed on communication circuits can be found in ANSI ATIS 0600-337-2016. So this informational note sends us to another ANSI standard, and that standard is called Requirements for Maximum Voltage, Current, and Power Levels Used in Communication Transport Circuits. So that's what that 805.17 is about. Article 810.2. Article 810 is radio and television equipment, right? So 810.2 definitions. The definition in Part 1 of Article 100 shall apply, right? So I believe that's how they're trying to harmonize the 800. They're making reference back to Article 100, and they're saying, well, Chapter 8 is not really this black box, but the definitions that have been used throughout the rest of the code also apply here. 810.21, bonding conductors. Let me see. The revision to add copper-clad aluminum. So that's the short version, and the long version is bonding conductors and grounding electrode conductors receiving stations. That's what Article 821 is called. And A is material. So under 810.21, we have a section that is called material. And the materials, the bonding conductor or grounding electrode conductor shall be of copper, aluminum, copper-clad steel, copper-clad aluminum, bronze, or similar corrosion-resistant material. Now, at this point, you should at least realize the bonding conductor or grounding electrode, right? So we talked about those. I can go back to the picture again if you'd like to see it, but grounding electrode can be copper or aluminum or copper-clad steel, copper-clad aluminum. And also the bonding conductor can be the same. So that was a clarification made in this 810.21a. All right, let's go to 840.2. New definition for broadband and premises powered. So what's the new definition? So broadband is wide bandwidth data transmission that transports multiple signals, protocols, and traffic types over various media types. That's what the definition, that's how the Nfpa 70 defines broadband. And power on the premises powered, they're defining as using power provided locally from the premises. So to me, that means you don't have utility. You have a microgrid. That new term microgrids or microgrid only means you got a local generator or you got a local PV supply, PV station that only supplies your local needs. Or you might have in the back of your house a wind turbine that also can be local powered. So premises powered, it means using a local power from local premises. Let's see, 840.102. Let's see, and then this one has to do with includes lighting protection, lightning protection requirements for circuits that leave a building. So 840.102 is called premises circuits leaving the building, where circuits leave the building to power equipment remote to building or outside the exterior zone of protection defined by the 46-meter, 150-foot radius rolling sphere. The installation of communication wires and cables should comply with 800.100 and 800.106, and the installation of coaxial cables shall comply with 820.100 and Article 800.106. Okay, so I just mentioned a couple of things in here. First of all, we're talking about lightning protection, and the NEC is moving towards a metric system. That's why I mentioned 46 meters first. The 150 foot was in parentheses. So if you look at previous NEC codes, you may see the meter system in parentheses or in brackets, but and the 150 foot. But now I think they're trying to harmonize with other parts of the world where the metric system is more used. So, and then the informational note, right? So what's the informational note? The informational note, Nfpa 780, 2017, standard for the installation of lightning protection system for the application of the term rolling sphere. So I have done lightning protection studies, and yes, you do use a rolling sphere. Now, if you're in a substation, or if you're in a substation where you have outdoor power equipment, there are other IEEE standards for doing this rolling sphere. But for general industry, 150 foot is what I would use to do a rolling sphere. And what does it mean? So I wanted to go back to this picture real quick, right? So if I have a lightning strike right here at the top, that's probably what's going to hit most likely. So from this, one of these may be a lightning rod. It might not, so maybe both of these are lightning rods. Would have to ask Steve. He knows more about communications than me, but maybe one of these is a lightning rod. And when you have lightning, it will hit that rod, and that rod is tied right to ground. So there's a lightning cable that is basically a grounding cable, but it's braided. Has a lot more braids than a normal grounding conductor. I think usually 17 to 19 strands of conductor versus I think 5 or 7 for a regular ground cable. But that article talked about having so when you do the 150-foot sphere, you just put a sphere right here, and wherever it hits, or wherever it doesn't hit, is considered to be protected, because lightning most likely would hit the highest point. So that's what this article had to do with the premises, the light, that NFPA 780.
Okay, looks like we have another question just came in.
Yes, sir.
He says, can you go over article, let's see, this is, actually, I'm not sure who it's from, but can you go over article 700.12, section 8, generator set 3, dual supply, fuel?
Okay, let me see,
700.12b, it looks like.
All right, that's B. Equipment design and installation. Equipment shall be designed and located so as to minimize the hazard that might cause complete failure due to flooding, fires, icing, and vandalism. So, yeah. I lived in Houston. For you that didn't know, you know now that I used to live in Houston. And I lived through Allison, Tropical Storm Allison. So what happened in Tropical Storm Allison? Maybe those who lived in Houston during that time know that you could ride your jet ski in downtown Houston because the whole thing flooded. So what was bad about that? Well, at that time, and this was 2000, 99, 2000, around that time, all of their electrical equipment, including generators, including switchgear, transformers, were in the basement because that is the cheapest way to put a generator. I don't need to be getting it up to the top floor, to the penthouse, because it costs money. I got to bring a crane. I got to bring specialized equipment to bring that equipment up there. So that revision here, to me, this says that I need to protect my equipment so that I don't cause flooding to it. I don't cause fire, and I don't cause icing. So icing, to me, if you leave it outside, right? Or if you have, now, in some of these rooms, yeah?
It looks like he's specifically referring to B3. He's talking about dual supply fuel.
All right, dual supply fuel. B3.
700.12 B3.
Yep. And 700.12 B. Okay, 3.
If you're not seeing the same, it might have changed.
Well, B3, is it battery powered and dampers? No, that's D. Well, see, battery.
He's specifically asking about generator set dual supply fuel.
Design.
It may have changed over the years.
Well, I'm looking at the code right now. So let me look up 2017. I have that code right handy here too. So let me make sure that we're talking about the same thing here. Because that, like you said, it may 700.12b is a new section in the 2020 code.
Okay.
Yep. So B3 dual supply. Yes, this is the 2017 code. So prime movers shall not be solely dependent on a public utility gas system for their supply. Okay. So means shall be provided for automatically transferring from one fuel supply to another where dual fuel supplies are used. Well, I have not dealt with these type of systems, but I have driven into a Ford truck of a commercial vehicle that had 2 tanks. So I'm assuming that if I'm operating under this requirement, I would have to have a way to transfer the fuel system from one supply to the other. And then there's an exception. Well, I guess you didn't want to get it. The exception was where acceptable to the authority having jurisdiction, the use of other than one site fuels shall be permitted where there is a low probability of a simultaneous fuel or both off-site fuel delivery system and fuel from the out. So again, I have not dealt with a lot of generator systems. Perhaps these are in more of in healthcare. So my experience has not been heavily as healthcare. I have done industrial systems, and in my experience, I haven't had to use that. So, but if you need help, I've got contacts with Kohler. We've got contacts with Cummins, and I can provide some names that can actually be of more help than I can. Even Generac. So, if the gentleman would like to find out more, then I can at least provide them a name that they can go to. So, wrapping it up here. Let's see, power circuits. Let's talk about the 840.160 power circuits. Power over Ethernet systems are allowed to provide power to communication equipment via the communication cable. So as more power is delivered to the equipment, overheating of cables become more of a concern. Therefore, how cables are bundled together must be monitored and accounted for. cables are required to comply with Article 725.144 for communication cables used as Class 2 and Class 3 cables. So I'm not sure if, and this is, and I'm at question and answers, but NFPA 70 changes and updates. Pretty much we're talking about what has changed or what was being updated in the code. If there are specific items that we need to look at, and I mentioned, the code is very vast. It's very, it looks at many installations, and some of the audience asked some questions that I might not have been familiar because I have not had that, and I didn't work in those industries. But definitely we can help, guide you to the right people. So with that, Steve.
Yeah, it's a pretty massive code. It's hard for anybody to know every part of it, isn't it?
That's correct, and that's the reason I try to prepare only certain aspects of the code, and just to give you a flavor of how vast the code is. So, and then we got into NFPA 70E, which is a totally different. That is a standard. So one thing to note is that NFPA 70 is code, and sometimes it says it's shell. So wherever it says it's shell, that means that is the minimum requirement. NFPA 70E, that is not code, but OSHA, if they do come into your facility, they will look at 1910 CFR 29/1910. So, Georgia will not operates still under NFPA 2017 this year. Next year, it will have adopted NFPA 2020. There are a few states, I don't think many, that have already adopted 2020, but by next year, most of the states will have adopted the new code. So, any other questions?
Yeah, let's see. There was one other, looks like a question from Jeff, whether you see anything entering into the code in the future, I guess, or possibly the current version regarding EVs drawing power from electrified roadways. So basically some sort of induction or anything from the road itself.
Well, that's already done. If you go down to Georgia, between the Alabama and Georgia border, go take I-85 south, and when you come back into Georgia, you will notice some trees that look like, they're PV panels on top of trees, and they've already got a system to be able to do that charging. So that's already in place, and I would presume it would be covered under this 625 article that I've discussed. So yeah, definitely that would be more elaborate. That's going to get it. As these systems, I guess, as the technology gets developed more, it will be, the specifics will be added to the code. Thank you, Jeff.
Okay, great. Anybody else have any questions before we call this one a wrap? Okay, looks like that's it. So on behalf of not only the Atlanta Metro chapter, but also the State Society for the Georgia Society of Professional Engineers, I would like to thank you very much for taking your time to do this presentation and bearing with some of our technical difficulties. And I hope everyone understands this was our first time. So thanks for bearing with us. And Ken will be emailing out your PDH certificates as long as you get him the information. And with that, thank you very much. And I hope everybody has a great evening and stays safe. And Luci, if you want to say any final words, go right ahead.
Yes, sir. Appreciate the time. Definitely GSPE, and for allowing me to talk about the NFPA 70. And appreciate everybody that attended this evening. So with that, have a great evening.
We hope you
And good
enjoyed
night.
this
Thank you.
recorded presentation given at one of the Atlanta
Okay,
Metro Chapter
we
meetings
are
of the
out.
Georgia Society of Professional Engineers, an
All
affiliate
right.
of the National Society of Professional Engineers.
When I
Find out more about
reviewed
us
this yesterday,
or to
I thought
join
it was going to
us,
be like half an hour,
check us
but I
out
knew
at
if I speak a little
gspE.org.
bit slower, I can make it longer. You still hear me, Steve, right? Dave?
Hold on.
End online